Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in. Today we're looking at similar triangles. So we looked at similarity in maths in a previous lesson, and we went through a specific definition. So I'm not talking about similar the way you use it in everyday language. In maths, remember, two shapes are similar if they have pairs of equal angles, all angles are equal, and all sides are in proportion. So today we're going to narrow our focus to triangles that are similar. So let's look at these two triangles here. So these two triangles are similar. They have three pairs of equal angles. So this angle corresponds to this angle, and I'm telling you they're equal. This angle and this angle, and the third pair of angles as well. Okay, so there's three pairs of equal angles. So we have all angles equal. The sides, lengths of the sides are not equal, but they're in proportion because 12 over 6, so this side corresponds to this side, is the same as this side divided by this side, 14 over 7, and that's also the same as 16 divided by 8. All of them are equal to 2. So these sides have all angles equal, and they have sides in proportion. That meaning I multiply each of the sides in the smaller triangle by the same number to get the sides in the larger triangle. And because 12 over 6, 14 over 7, 16 over 8 equal 2, the scale factor is 2. So these two are the same shape, they're the same type of triangle, they have the same orientation, however, they're not the same size, and that's the difference between similar and congruent triangles. So congruent triangles are the same shape and the same size, whereas similar triangles are only the same shape, okay? So let's say we wanted to determine whether or not two triangles were similar. So you're probably thinking, okay, we'd have to check all the angles, all the pairs of angles are equal and all sides are in proportion. But fortunately, we don't have to check every single one of these. Just like for congruent triangles, there are tests. So remember, if I wanted to test that two triangles were congruent, I didn't have to test all sides were equal or all angles were equal. I could use one of these tests. Or if all sides were equal, then all angles would be equal, and so the shapes would be congruent. Remember in SAS it was two sides and the angle between them. It must be the angle between them. And there was also AAS and RHS. So if any of these tests held, the triangles were congruent. If, for example, I had two triangles, they each had a right angle, they had an equal hypotenuse, and another pair of sides was equal, then they were congruent. I didn't need to go and test all the other angles and all the other sides. So there are analogous tests for similarity as well. So two triangles are similar if they follow one of these tests. So the first test is SSS for similarity, but we just have to understand the difference. In congruent triangles, S meant a pair of equal sides. So they had to be the exact same length. Whereas for similar triangles, S just means sides in proportion. So SSS means that all three sides are in the same proportion. So if all three sides are in the same proportion, then all angles will be equal and the triangles will be similar. We also have SAS. So again, A still means angles equal. A means the same for similarity and congruent. It's just the S that's different. So incongruent, A means equal angles as well. So SAS means two sides are in proportion and the angle between those sides is equal. Now in similarity, there's not an AAS test. You can't have just one S. You can't have just one pair of sides in proportion. But we have the AA test or AAA. If there are two pairs of equal angles for triangles, then the third pair of angles will also be equal because of the rule of 180, the fact that angles add up to 180 degrees. So if two triangles have all their angles equal, then their sides will also be in proportion and they will be similar. The last one is the same RHS, so R has the same meaning it means they both have a right angle. But here H and S, hypotenuse and side, refer to sides in proportion, not sides being equal. So let's look at a couple of examples. So let's say I have these two triangles here. I've got no information about the angles. So I don't know at this point whether all angles are equal, but I can still say that these are similar. They are similar due to the SSS test because the sides are in proportion. So how I show that sides are in proportion, I take a side in the larger triangle, divide by its corresponding side in the smaller triangle, and I should get the same no matter which sides I use. So 45 over 15 gives me 3, 54 over 18 is also 3, as is 39 over 13. So these sides are in proportion because for each side in the smaller triangle, I times by 3 to get its corresponding side in the larger triangle. So here they are similar due to the SSS test, and the scale factor is 3. So I don't need to mention anything about the angles. But what it does mean is that this angle and this angle will be equal. If this angle was 30 degrees, then this angle here would be 30 degrees. If this angle here were 47 degrees, this angle here would be 47 degrees, okay? So they aren't the actual sizes of the angles. I'm just letting you know that because we've shown that all three sides are in proportion, these two triangles will have 3 pairs of equal angles. So let's look at another example. So I have actually 2 triangles here. I have the big one that goes like that, and I also have the small one that goes like that. So these 2 triangles are actually similar. Now, when I'm not given any information about sides, the lengths of any sides, then I know that they must be, if they're similar, it must be due to the AAA test, all angles. So I know that because this line and this line, because they're both parallel, I should be able to find some equal angles. So this angle and this angle will be equal because they are corresponding. That's the F shape there. That's what I went through in lesson 1, and that's why we did it. So those 2 angles are equal because they're corresponding. This angle and this angle are equal. They're also corresponding angles of parallel lines. This angle here is actually in both triangles, so it's obviously equal in both triangles. So these 2 triangles will be equal due to the AAA test, or if you like AA. Okay, once you know that 2 pairs of angles are equal, the third pair of angles must also be equal. So we can use that to solve problems. So let's say that this side here was 4 and this side here was 10. Now, because I know that these 2 triangles are similar, then that means all sides will be in proportion, and the scale factor would be 10 divided by 4, which is 2.5. Okay, and I can use that to find some unknown lengths. So let's say, for example, that this length here was 8. What would this length here be down here? I'll call it X. So this is just like problems we solved using similarity in previous questions. So I want to find a side in the larger shape, so I take the side in the smaller shape and multiply by the scale factor. I get 20. Okay, easy as. So let's now look at actually proving that 2 triangles are similar. Okay, so I have 2 triangles here, the smaller one ABC and the larger one DCE, and I want to prove that they're similar. So in the previous questions, I just explained why they're similar. I mentioned the test. Here I've got to go through, just like I did for congruent triangles, and show which angles are equal or which sides are in proportion one by one, and actually explain further why they're similar. Okay. So firstly, we have pairs of parallel lines, so hopefully we know that these 2 angles here are equal. That's because of alternate angles. So this angle here is that I've just coloured in blue, so that will be angle ABC. That is equal to angle CDE, which is this one. Now, I don't know what the size of each angle is. I just know that they're going to be equal due to alternate angles. Okay, this one here and this one here, they must be equal. So angle ACB equals angle DCE, and the reason is vertically opposite angles equal. Okay, so because I found two pairs of equal angles, the third pair must also be equal. So this angle here and this, I'll colour in red, this angle and this angle must also be equal because of the rule of 180. They're also equal because of alternate angles. So angle BAC is equal to angle CED, and you can use rule of 180 or alternate, whichever. Okay, so when you've got three things, just like for congruent triangles, there are three things here, then you need to write a similarity statement. So I'm going to do that up here. So you say, therefore, triangle ABC, this means is similar, or you can use this, either symbol for similar, doesn't matter. Now, to write the second triangle, remember vertices have to line up. So this angle at A is equal to this one here. So A, vertex A in the first triangle corresponds to E, vertex D corresponds to B. So I have to write E first because it corresponds to A, D second, and then C last because it corresponds to itself. So triangle ABC is similar to triangle EDC, and of course the reason is AAA. I just put that in brackets. So I've now proved that they are similar. So I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.